Let's walk through a few examples of setting up these integral statements for calculating these area between curves. So one of the main things to keep in mind is that we need to know which of these functions is taking on the larger function value over this given interval. So we have two lines to consider, y equals negative 6x minus 7 and y equals 0. So to integrate this, we need to know of those two functions, which is taking on the larger values. So using a graphing calculator, if we go to the y equals screen, we can type in negative 6x minus 7, set y2 to be 0. So now we've got our two different lines or two different curves being graphed. The next thing we can do is go to the window screen, adjust our x-min and our x-max to match the given domain for the function. In this case, it is negative 1 to 2. And then to help your calculator kind of zoom in to give you a better view of your graph, if you go to the zoom screen and down to the 10th option, zoom fit, what this will do is automatically fit the y-axis to include your entire graph on the screen. So that's not quite showing up in the large screen view over there, but we can see it over here. So at the very top of our graph, we have the x-axis, which is that line y equals 0. And then we have our other line, y equals negative 6x minus 7. So in this case, y equals 0 is taking on the larger function values over this interval. So we would want to set this up as the integral from negative 1 to 2. We would start off with the larger function value, which is 0, and then subtract out the smaller function, or the function with the smaller function values, to construct that integral statement. So now what we can do is simplify it to rewrite this as the integral from negative 1 to 2, and then we can distribute this negative sign through. So this will become plus 6x plus 7. So we're integrating the function 6x plus 7 dx, which will become 6 times x squared over 2 plus 7x, which then we'll want to evaluate from x equals negative 1 to x equals 2. So substituting and evaluating this function at x equals 2 would give us 26, and then we would subtract evaluating that function at negative 1, which would give us a result of negative 4. So that would become 26 plus 4, or 30, as our total area between those two curves. In example 4, we could start this process off the same way. You could go back to your calculator, you could graph these two functions to determine which is taking on the larger function values on this interval from 0 to 1. In this case, it would be y equals 4, taking on the larger function values. So we would want to integrate from 0 to 1. We would take the first function, 4, since it would be taking on the larger function values, minus x times 1 minus x, or if we distributed that through, this would become x minus x squared. So taking the function with the larger function values, minus the function with the smaller function values, and then simplifying what we have in here, this will become 4 minus x plus x squared dx, or 4x minus x squared over 2 plus x cubed over 3, which we would then want to evaluate from x equals 0 to x equals 1. So evaluating this expression at 1 would give us 23 sixths, 23 over 6. Evaluating it at 0 would give us 0. So we get a result of 23 over 6, or if we were to round that, approximately an area of 3.833. In our next example, we again have two curves to consider, though the language of the problem is a little bit different. So we're told that one line is y equal, or one curve is y equals 7 over x. We're given a domain from 1 to 5, and we're told that we want the area between the curve and the x-axis. So that language that we want the area between the curve and the x-axis gives us our second line, or our second curve, y equals 0. So in this case, we would want to integrate from 1 to 5. Graphing these two functions, we would see that 7 over x takes on the larger function values over that interval. So we would integrate 7 over x minus 0 dx, which is just the same thing as integrating 7 over x. So the integral would be 7 times the natural log of the absolute value of x, evaluated from x equals 1 to x equals 5, which would give us 7 times the natural log of the absolute value of 5, minus 7 times the natural log of the absolute value of 1. The natural log of 1 is just 0, so that second term is gone, and we're left with just 7 times the natural log, and then we can evaluate the absolute value of 5 to be just 5. So we get 7 natural log of 5, or using a calculator we could come up with an approximation for that area.